Hello.
Right. Yes, YanKeen, I can hear you. Can you hear me loud and clear?
Yeah.
Okay. Okay, I'm on my headset. Oh. Okay. Yes. YanKeen, how are you?
Fine, I think. I did physics today.
Yeah.
And I think it when fine. There was a bit on polarization graph that I couldn't do. But other than that, I think I have most of it down.
Better than expected, I would say.
Yeah. I'm not. I mean, I could still get stuff wrong. But as a sense, I'm confident for most of the paper.
Still sounds not so bad, right? Fingers crossed. Hopefully, you will get some interesting results.
Yeah.
Right. Okay. So what is left is to concentrate on math then.
Oh, just Chem.
Just sorry, Chem. Forgot about that. Right. Okay. So Chem. Right. Any honest question?
Yeah, B part 2.
Okay, wait. Sorry, the connection. Okay, there you go. Okay, I'm gonna take a picture of that. Right. Okay, still clear enough. Oh no, too far away. Okay, there you go. Thank you. All right, let's stop there. Okay, we're using the previous Jamboard, which is
I don't think you made one on Sunday.
Yeah, as in that one. All right. Okay. So then we're going at page 12. Yeah. All right. So tell me what your question is.
Right. So I'm not sure how the well, I mean, I know how the ammonia reacts for part 1.
Oh, it's still this question, right? Okay, right. It's still this question, right?
Yeah. There's a question later. But that one is even more. What the hell is going on? So I know the equation for. I know the equation for the ammonia reaction. This one, but I'm not sure how to. I know the equation for like reactive ammonia because like the question part 2 says must react with ammonia, right? Mass ammonia react or whatever.
Wait. Sorry. I'm not getting any ammonia. Sorry, I'm very confused right now.
Oh, I'm not talking about ammonia. No, sodium hydroxide.
Sodium hydroxide. Okay, sodium hydroxide.
Yeah.
Then
with sodium hydroxide. So the question says obviously react sodium hydroxide to get pH 7.4, right? I'm not sure how to get specifically 7.4.
Wait, no. Yeah, okay. Yeah. Okay, so I was just confirming that this has no connection with the first part. Or rather, no, I don't think so. Okay, just confirming that. Okay, I'm gonna start that. Okay, great. Okay, so you have a reaction. Let me see. Yeah. This is what you're doing is a. Oh, sorry. Never mind the part. Like the reaction seems to make sense to what you have written because it seems like it's a acidic H2PO4 minus, right? Basically, reacting with a base, which is NaOH.
Yeah.
A few drops, I agree. So the NaOH will be limiting. So I think we'll have more of that. Okay, right. So let's just say that we found some sort of a neutralization reaction. That's it, right? Right. A neutralization reaction doesn't show a buffering ability, right?
Yeah.
So you're quite advanced in buffer already. So a buffer reaction or reactions are not like this. This is neutralization. So if they're asking you to show as a buffer, then I believe we should write more, I suppose. I know he say by means of a balance equation, but a neutralization reaction does not get you there yet, I suppose. What does a buffer reaction look like usually?
I mean, there's also acid, I suppose.
Right. Okay. We went through this. So write down a buffer that you know, like really. Write down a buffer that you know will be a buffer.
Oh, let me just check.
No.
I
Like
come
from
up
your
with
mind.
one,
Yeah, come up with one. Right, come on.
I mean, it needs to be a CH3COH.
Oh, you write it down next to this question, right? Write it down. CH3COH, right? Okay. So, okay, you start with this. And I was hoping that after this, you'll write a reaction or another component needed for the buffering ability, right? Okay. Right. Oh, and I need to see the form of reaction if there is such, and the other component needed for the buffering ability to happen. Right. So you write CH3COH and that salt. Okay, great. So what kind of reaction are we expecting here?
I mean, this one? What do you mean hot reaction?
No way, man. No way, man. Like from the start in buffering, no. You don't have to involve NaOH, right? Or rather, I don't think you. Fine. You can write this. You can write this reaction. Go and write this reaction because it will produce the salt that you want, right? I suppose.
Produce this thing, and then this thing will just react with acid to produce back this thing.
Okay, write down that reaction first, the neutralization. That's fine. Okay. But then I need another reaction. Addition
of acid. Or is it the equilibrium reaction?
Yeah. The reversible reaction. There is no buffering without a reversible reaction. Does that make sense?
I guess in theory.
In theory. Oh dear. Right. So how does these two reaction or two component or two what? I don't know. How do they work to buffer?
Well, once you react NaOH, then it forms this ion.
Yeah.
So
okay.
there's excess of it here in this equation. So the system will try to shift the equilibrium position to this side. So there'll be more of this one.
All right.
It doesn't completely restore it, but like it goes back up.
No. So there'll be some of the ion, the negative ion, very little amount of the H positive, right? Very little amount, and an increasing amount of the original CH3COH, right?
Yeah.
So how is that a buffer? How does that work as a buffer? What does buffer mean? I'm sorry. What does a buffer mean? And I don't mean CH3COH and CH3COO and A is a buffer. I don't mean that. I mean, what's the function of a buffer?
I mean, it keeps the pH almost constant, right? When
So what does that mean? Small amounts of? Yeah. So please describe using whichever reaction, whichever that makes sense. Please describe what happens when you add a small amount of H plus, right? And a small amount of OH minus. Which reaction will help you explain that?
This has OH minus, right? On addition of small amounts of OH minus, then.
No, that's not true at all. So no.
Wait a minute.
No. Okay, let's start with the H plus first. Right. Let's make it easy. You have two reactions, right? So what happens when you add more H pluses?
What happens when I add more H plus? It will react with the ion of CH3CO minus, I guess.
All right, and then what will happen as a result of that?
H plus is removed. And excess CH3COH is created.
Right. So when you add this, right, you can just say the normal stuff. Equilibrium will shift here, right? When you add some of this, equilibrium will shift.
H plus. Equilibrium will shift
To
to
the left, right? Therefore,
Yeah.
reducing the H plus. Not completely, but reducing the additional H plus.
Okay.
This doesn't connect. That is how you buffer the H plus, by reducing the H plus added.
Just through equilibrium.
What
I
else?
thought it was more complicated than that.
That's precisely my point. I'm very confused right now that you don't get this. You should get this. Oh, I can reduce the effect of the additional H plus because I am a reversible reaction.
No, I thought it was like a.
No, that's it. For the H plus lah. That's it. No, really, that's it. Really.
Okay.
How about the OH minus? How do I reduce the additional OH minus coming in?
Well, you just add the once we add in the react the acid, then S to create the additional CH3CO minus.
Right, this one.
But
So
then,
this reduces, right? This reduces, this increases, right? This reduces, this increases. So the OH minus be gone for a while, but notice that because this reduces and this increases, you will have a shift also.
To the right?
To the, no, this reduces and this increases. How can you shift to the right?
So
You'll shift. You'll shift to the left also, right? You'll shift to the left. Yeah, you'll shift to the left also. So again, reducing the amount of H plus, which is a bit counter, just a bit of a counter to the reduction of OH minus. Because when you add OH minus, you want to reduce OH minus, right? That's what you want. But that will happen, but the equilibrium will also reduce amount of H plus. So just countering the OH minus reducing effect by a bit. Still working, still the buffer is working, is what I'm trying to say. If you add too many OH minus, now if you add too many OH minus beyond the maximum buffer capacity, what will happen?
Yeah, I guess just say it. I mean, you just react the S like
this will reduce a lot, right? This will reduce a lot. This will increase a lot, correct?
Yeah.
And then the equilibrium will shift back to the left, until it can no longer do so, lah. Right? It can no longer do so. Right. So that kind of that probably signals almost the end of the buffering capacity when you add more OH minus, lah. That's the when you end it, lah, so to speak, lah. You can no longer buffer it. What happens when you add a lot of H plus?
A lot of H plus?
Yeah, a lot of H plus.
I guess you run out of
this one, you increase a lot, and this will run out, lah. This will run out, so to speak, lah.
CH3CO minus.
And therefore you can no longer shift to the left, and therefore you can no longer buffer. If that makes sense. So the end of the buffering of H plus is when this is gone, so to speak, lah. And the end of the OH minus buffering is not so correct, but when this is gone, something like that. Something like that.
Okay.
Okay. Now here's the last question. Do you really need this? Can this be used to buffer? If we just need this, is there a but, or oh yeah, this can buffer? Simple, done. Right. So I want you to think about it. I want you to think about it. Right. And the answer is no, half no. Half no. Huh? So if I only have this, can I buffer additional OH minus?
Can you buffer additional as in exceeding buffer capacity? Or just...
No. Still below, of course, still below lah. Just still below.
Well,
can handle.
You'll react with the
acid. right?
Yes. Yeah.
So I guess that can handle it. Can handle, right? What happens when you add H pluses?
We add H plus, then there'll be excess of H plus. So,
So
I suppose, is it? Then you'll react with the C3COO minus to shift it to the left again.
Standard, right? So left shift, but the problem is why this is considered cannot, because you will run out of CH3COO minus quickly, very quickly. You will, because remember, it's a weak acid. Originally, this reaction is a lot of this and very little and very little. You will run out of this very, very fast. Therefore, this alone is not a good buffer because it can handle more base. Obviously, right? It's an acid, it can handle more base, but it cannot handle more acid. Cannot. I suppose that makes sense. A weak acid cannot handle more acid. Obviously, it will just increase in acidity, I suppose. You want a weak acid to be able to break the increase in acidity. You gotta increase him, if that makes sense. Increasing him will increase the capability of absorbing H pluses. Then you wouldn't.
So I just need to add in, right?
CH3CO minus, and that's why this is a buffer combination, not because of this guy, because of that guy, that guy.
Excess of the.
Adding more, so to speak. Adding more of this will increase its capability of absorbing H pluses. That makes sense,
right?
And therefore, although this reaction is extremely important in providing this, the buffer action happens here. Right, the buffer action happens here, right? You are still not getting it, really. You're still not getting if you think that this is a bonus chapter in buffer, I actually explained this at the start. That is buffer, not the formula. By means of a balanced equation, show how the mixture can act as a buffer with no. If you're convinced with your reaction here, your first reaction, you wouldn't be asking me. But this reaction is correct one. So we'll move on to part 2 lah. But you're not convinced. Why are you not convinced with the reaction that you wrote?
Because I can't do anything with it, I guess.
I suppose it doesn't look like a buffer. It is not a buffer. The reaction that you wrote is not a buffer. It is potentially one component of the buffer. You know that buffer have 2 components, and therefore it must be illustrated by at least 2 reactions, if that makes sense. Just write down 2 reactions first, even though the question say by means of a balanced equation. Just write down 2 first. An interesting reversible reaction. One which, can you shift up a bit? One which include this and that. So it's starting to make more sense, I suppose, right? It's starting to make more sense, right? Okay, so now in your second reaction, let's focus on the second reaction. The second reaction is similar to this guy, right? How does the second reaction, yes, you're saying?
I gotta say, I'm not sure where the second A will come from.
The second who will, the second what?
Like on the Jamboard, the second NA.
The second NA, which one? Which one? The second NA? Which one?
On the Jamboard, I'm circling it.
I'm not seeing anything. We're doing a Jamboard, page 12, right? Oh dear, is it very lacking? Okay, now I'm circling something. Do you see what I'm circling immediately?
Yeah, I see what you're circling.
Oh, but your circle just come just now. Okay, understand. So where does that come?
Na2HPO4.
Yeah, where does that?
Where does that?
Yeah, so let me write down your second reaction more appropriately first. Let me write down your second reaction more appropriately. Your second reaction is actually only like this. If it makes sense, minus reversible HPO4 minus plus H plus. I hope this makes sorry, this would be 2 minus.
It's 2 minus.
Which one's the 2 minus thing? Yeah, that one will be 2 minus. That one will be 2 minus. This is what you need to worry about. This is the reversible reaction. The Na plus doesn't play any part or any role. Remember, it's an ionic reaction. You can just cancel the Na1. So therefore, you don't have to think about the Na at all. You don't have to.
Oh.
If that makes sense, I'm not cheating here. The Na plus doesn't really play any role at all.
Yeah, I can. Yeah, sure. I can go with that.
Same thing with this one. Same thing with this one. Sorry. Same thing with your buffer example, which you did correctly. You are interested in this guy, ma. You are never interested in the Na plus. Who cares? Even though it's there, lah. Who cares, right? Who cares about the Na plus? So same thing. Your first reaction might appear to have Na, and the Na might appear to be important. It's not. It's not important at all for the buffering ability, but it's there, lah. It's there. Okay, Ken?
All right.
So I feel the second reaction can be simplified like this, and you already settle your problem, the Na problem, right? So from your first reaction, you have an additional supply of this one. You have an additional supply of this guy, correct? Correct or not? The additional supply, that's what you're pointing at. Yeah, or 2 minus,
yes,
is being additionally supplied to this. Now think about this. Is this a good idea for in terms of buffering, or is useless, or what?
Is it a good idea? Okay, so when I add H plus
HPO4 2 minus. Oh yeah, when you add H plus,
HPO4 2 minus will be in excess. Excess, and so that it can deal with the excess of H plus. Yeah,
you can shift to the left more, so to speak, because you have more of the HPO4 2 minus, right? Makes sense.
So if I add OH minus, then there's already an excess of H2PO4 minus.
Put it this way: if you add additional OH minus, you react with the acid. Simple lah.
Yeah, and there's already a lot of it.
Yeah. Or you can just refer to the first reaction. So happy lah. So happy with that. So I can deal with it. Now you're thinking like buffer. Oh my goodness. The 2 sentences you mentioned just now, I can deal with H5 minus according to reaction. That's buffer. That is buffer. I can safely say that if you didn't understand that, but you do right now. If you don't understand this, you're going to the exam half blind. Only formula, not going to help you much. But with that understanding, you can handle many types of questions, including this one. Again, I'm not sure why B1 mentions one equation. I'm very confused right now. Am I supposed to select? If I'm supposed to select, I'm going to select the second one, but it doesn't make sense. I think I'm supposed to write both. At this point, if this is exam, I don't care. I give you 2. Boom. And then I'm going to explain a little bit. So I'm going to explain based on exactly what you say. Exactly what you say. That is the explanation.
So on addition of H plus, there's an excess of HPO4 minus provided
2 minus. HPO4 2 minus provided by the first reaction. Yeah, for the first reaction. Right. And therefore, when
therefore the pH is able to remain relatively constant with excess of H plus.
H plus and OH minus is added. You can explain that even further. Easy for you.
Right.
Yeah, and that will be, I believe, part 1. Yeah.
Okay.
Considering the mark, I think it's reasonable to expect. Now, part 2, right? Calculate the mass of solid NaOH that must be added in the mixture so that pH. Yeah, that one is now a formula. Okay, I agree. Which I might add, I think you need both this reaction also. For part 2.
Both those reactions.
Yeah, rather you need to have these 2 reactions in. If not, then I think it's very confusing. You try doing part 2 because part 2 is very normal. referring to the formula is enough, but I guarantee you it makes sense when these two reaction is written in your mind. I'm very sure about that. I'm very sure. Please give it a try.
Let me just rewrite this. pH 7.4. How do I get that?
Yeah, so you must work backwards lah. So I want basically a buffer at 7.4, right?
Okay.
And 7.4 is determined by a pH of 7.4 is determined by in this case,
in this case,
in like pH, right? pH of 7.4, pH of 6, pH of 4 is an indication of the concentration of H.
H plus, yeah.
H plus, which therefore you should at least start from there.
Really? Can I?
It doesn't make sense at all to you that it starts from the concentration. It doesn't make sense.
I mean,
you can do something else. You can do something else. Though. Yes, you can do something else if you want to.
Negative 7.5. Oh, that's.
You can do something else if you feel it's appropriate. A very small number, no doubt. Right. Actually, even smaller than the kW of water lah. The Ka of water lah.
Yeah. 1 times 10 to the power 97. Yeah. Okay.
Yeah. Right. So, at this point, are you stuck? Like, or do you have something else you want to do?
Well, I can find a concentration of these compounds in the 1 dmq of distilled water.
The mass of solid. Yeah, beside the mass of solid. So you can, yes, you can calculate the concentration of Na plus from NaCl, right? The Cl minus doesn't matter, right? The concentration of the HPO4 minus, the concentration of H2PO4 minus. Yeah, sorry, 2 minus and minus. Yeah. Oh, you can calculate the concentration of Na plus if you want to, but again,
Don't think you need it.
No, not yet. I don't think it is important. I don't think so. With Vex, why do you add NaCl? So let me think for a while. Why do you add Na plus? Yeah, you can do that if you want to. You can do that if you want to. Think after that the question will just be the same lah. There's a question that you must answer.
So Na2HPO4 is 142.
Go ahead, write down. Right. Concentration of what is that? The concentration. Okay, never mind.
I need to find the mole first one. So
sure. It's not a very nice number. Dang.
yeah.
I was hoping that it's just 144 lah, right? But that's basically just 0.01. Yeah, 0.01 basically lah, right? I don't think the other number matters. Yeah, I don't think so. Right. Okay. A bit weird, but okay, right?
For the concentration of Na2. How am I doing this? Just HPO4.
Yeah, HPO4 minus is the important guy here, I feel, right? Yeah.
HPO4
definitely. Minus. Yeah, definitely. Yeah.
So it's just same thing.
Yeah, because the water is just nicely there. Okay, nice, good. Right, mole per dm³. So great, we got that. And then make use of the space on the right. Yeah, okay. To do more, right?
right, NaH2 5 delete minus 120, right?
Uh-huh.
Yeah, 120.
Right.
120. Got that. H2PO 2 minus 2 minus.
I think you wrote the wrong thing. Actually, now that I look at it, I think you wrote the wrong thing. Yeah. So the HPO4 is 2 minus. And this guy is 1 minus. Tell me why?
HPO4 is 2 minus because, well,
Na2.
I mean, I could just say that
Na2. It's
Na.
Na2. It's Na2, man. It's Na2, right?
Yeah.
So 2 minus lah. And then the other guy is Na, man. So
NaH2. Yeah.
yeah. You can also say that I just lost 1 H, so only 1 minus. You can also say that lah, right? So we got all this lah, right? Now it's true that you can do that. Just remember that this 2 concentration is the origin, the starting concentration. Just remember that, right? Starting concentration. The concentration of H plus, if that means something, is the end concentration, the ending concentration. This concentration doesn't exist at the same time, right? Okay, the two that you did just now, we start with that. So far so good lah, right? So far so good. Now time is almost up, so let me ask you. At this point, it's obvious that we need some sort of formula and maybe some sort of reaction. Let's say that we have the reaction on top, right? What kind of formula? I think because there's only 2 formula for buffer that you need to memorize, right? You only need those 2.
Yeah, but both of them involve Ka.
Precisely my point. It's very bothersome. It's very bothering that the reversible reaction has no K. Let me confirm that you don't have the K for the reversible reaction.
No.
And because of that, the 2 formula of buffer, tell me what are the 2 formulas that you remember for tomorrow?
pH equals to pKa.
Yep.
Plus the log
of concentration of this divided by that. Correct.
Of salt over acid. So
right. So that's the pH of the buffer, right?
Yeah.
Correct. Which is the 7.4 lah. You can use the 7.4 in that thing, except that you're missing the K. Except lah. That's a problem. What is the other formula? The maximum buffer capacity, right? That's all lah.
Yeah, it's just pH equals to pKa.
Yeah. But I don't think that one applies here lah. I don't think, right?
No.
So it bothers me very much that you don't have K. It bothers you also. The hint is 10 minutes, right? The hint is I think that's why they have part A. I think. Because they don't give you K. There is no way to find K, or rather, not yet, in part B. I don't think there is a way to find K. I don't think so. Because K is always found experimentally. If that makes sense to you. K is not a formula out of nowhere. Cannot. So, the absence of K can be compensated by part A. I think my hint to you. You're saying, but
how?
Yeah, how? I know how. But at least part A is talking about that. Part A is talking no, let me see. Let me check. Formula of the chemical specimen present F. Wow. Okay, what's F again? Let's go back to F, right? At F, you have chemical species present H2PO4 minus, definitely related here. Just to be clear, at part E, you don't have that yet, correct? In part E?
Part E?
Yeah, in part A, point E, sorry, point E.
Part A point.
You don't have that yet. You don't have the H2PO4 minus yet. Am I correct?
No.
No. Right. Now, right. Yep. Yep. Look, more hints. This is a triple buffer. This is a triprotic, triple buffer curve, right? Triple buffer curve, correct? Right. Where's the triple buffer? Like in this kind of curve, they usually ask a very standard question. They don't ask it here, but usually they ask a very standard question, like calculate where the maximum buffer capacity appear, for example, right? Where is it? Yeah, that's the first and the second one, and the third one will probably be after that lah. But they don't. We don't care lah. We don't care. But there is, I think, conceivably a third one, right? Right. This is explored in your note very clearly.
At pH 2.2.
At pH 2.2, that's the first maximum buffer capacity.
That's the first buffer. So at maximum that buffer capacity, there's HPO4, there's HPO4, H2PO4 minus
and HTPO4. Yeah, that's one, which is not what.
Oh, but they say that 7.2.
Yeah, there's 7.2, which is the second maximum buffer capacity, right?
There's HPO4 minus and H2PO4 minus, which is
correct. Yeah. Of course, at 7.2, that's the maximum buffer capacity lah. Of course lah. Yeah. Right? Which is maybe relevant to our part B, maybe not, but at least we are at the proper reaction. At least. Again, notice again in part A. Again, notice in part A. Part A is adding NaOH to this thing lah, which is exactly what you're doing here. You're doing in part B what you're doing in part A. It's just that in part B you start off slightly differently only.
Okay.
Right. Okay. Maybe you can see something from there, maybe you cannot. But I'm saying that part A and part B, I think there's a connection. There is.
So at that pH 7.4, I've already exceeded maximum buffer capacity.
And not by a lot. Like seriously, it's not by a lot. Not by a lot. Like really not by a lot. Like, does the maximum buffer capacity provide you with anything? Oh my goodness. 7.2 maximum buffer capacity. Does it provide you with anything based on the formula? Oh, that's me.
Yeah, I guess with the pKa.
You can find the pKa based on the formula of 7.2. Boom.
And then I just plug that into
the other formula. Boom.
Oh yeah, and then I have this H plus, so I can find.
Yeah, boom. Or you can just use the pH. You can just use the 7.4. You don't need the concentration of H plus in the end.
Oh yeah, okay. Yeah. This pH 7.4 equals to pKa plus a log of a new.
Yeah, which you can find the pKa from the boom second buffer maximum buffer capacity. Boom. Okay, boom. Okay. So yeah, go ahead, do it, because we only have time for this. So do it. Complete this understanding. Complete your understanding. Maybe you write on the right or something. Make yourself a space, whatever. Oh, there's a part C. Okay, I didn't know that.
Oh, C is I tried doing it myself, but
right.
Wait, 7.2. Oh, that's just what we're doing. It's just pKa. Okay. 10 to the power -7. 1, 2, 3, 4, 5, 6, 7, 8. pH 7.4. Goes to 7.2 plus log of salt over acid. That's like the concentration of salt, which is the salt being HPO4 2 minus acid. H2PO4.
Yeah, which you have it from your calculation, which is great.
0.2, I can get rid of the log by 10 to the powering. Yes, yes. Wait, 10 to the power 0. 1.5885. Right. And if I need to find the mass of AOH, that must be added.
Right. So right now you have the ratio already, which means currently your original ratio might not fit lah. Maybe that's what he's saying, right?
Yeah.
So calculate the original ratio, or rather, yeah, I want you to think about this. I want you to think about this. And I promise you that the two reaction is helping. Or not, rather, I think it's necessary.
This is KC. Boy. I have to. Let's go back to my KA equations. What's the explanation? There you go. Okay. K. Is this a KA? It's a KA, right? Yeah, it's a KA. And I'm missing. I'm
Very confused, right? Are you very confused, right?
I think the KA, which is this one.
What?
I'm not sure if what I'm doing makes sense.
Okay.
So if I let me make sure I have this right. I have that.
It might make sense. I don't know. It might.
How does it get me to the mass? How does it get me to the mass?
Okay, I'm gonna stop you there for now because time is almost up. I'm gonna take a pic. Straighten.
Sorry, I'm not sure where to go on from here.
Yeah. I'm gonna paste your working. I have to go to page 13. Please go to page 13.
I mean,
Go to page 13. Go to page 13. Go to page 13.
Yeah.
Oh, still very slow. Oh my God. Sorry, it's loading very slowly. My goodness. Okay, good. Now,
Yeah, I can see it.
and let's call this the first reaction. Let's call this the second reaction, right? You're aiming at the second reaction. I don't think that's a problem. Now I want you to focus on these two. Just make sure first that their ratio is not according to what you need. Just make sure. Just make sure on that.
Yeah. Okay.
Like it's probably shouldn't be far. It probably shouldn't be far. Probably not far.
Yeah.
Yeah. How what's the current ratio? The original ratio will be.
So 0.104. Also, it's 0.0101.
I cannot see it. Yeah, I can see. Sorry, I was lagging. Yes, I cannot see it. Just read for me. What is it? Ah, there you go. Very nice. Oh my goodness, the ratio is very different. Wait, what? What? 0.476. Wait, let me think for what? Let me think. What? Oh yeah, I did. Huh. Wait. I just want to make sure that this is fine. I just want to make sure that this is fine. So just make sure that this part of the formula is correct. The original formula will list this as what?
Which one?
This part. The original formula will list this as the concentration of the what, and this is the concentration of the what?
That's the concentration of the salt, right?
This one is the salt over the acid, is it?
Yeah, salt mass, yeah. That's what I learned.
So just I'm going to refer to the second reaction. You will call this the salt, I suppose, and you'll call this the acid. And I suppose you're correct. Right. And please confirm that 1.585 is correct first, which is to say, I think you have to 10 to the power of 0.2. I think that's what you need to do, right? Is that what you did? Is that what you did? 10 to the power of 0.2? Yeah, okay. So no doubt there. Okay, good. So our ratio is quite different. So now let's look at reaction 1. I promise you that reaction 1 and reaction 2 is important. So currently reaction 2 is obviously important, right? Obviously. The one that you miss reaction 2 just now, like from the start, correct?
Yeah.
Remember that you will be needing the type of this type 2, this reaction, the second reaction in your exam. You will be needing it if they don't provide. Understand? Huh? You will be needing it. Now, let's refer to first reaction. My original ratio indicates that I am lacking. I'm lacking the HPO4 minus, correct? I have too much H2PO4, 2 minus. That's my original ratio. That's the indication. Am I correct?
Yeah.
I have too little of this. I have too much of that. Now let's look at our first reaction. How does our first reaction help? How does our first reaction help?
It turns the H2PO4 minus into HPO4 2 minus.
Correct. So the first reaction will reduce H2PO4, right, minus, and increases HPO4 2 minus. Is that what you need, or is that worsening the problem?
It's what I need.
Okay.
Too much.
Yeah, I'm giving you a lot of hints already, by the way. That is how you will find the mass of NaOH. You would notice that the mass of NaOH exists in the first reaction. You would notice that.
Yeah.
Still not enough. Like I'm gearing you towards the first reaction. Like look at the first reaction. The first reaction accomplishes what you need, and so happens there's also NaOH there. So you gotta do something with regards to that.
You find the mass of NaOH so as to make the concentration of this, concentration of these two, or the ratio of concentration of those two become 1.585. Oh man.
Yeah, I mean, well, yeah, the way you put it is the most difficult thing ever, but yeah, that's what you need to do, and that's why it exists.
Oh.
You have never seen this kind of question in your tutorial, really?
No. At least
I'm willing to bet. I'm willing to bet. I'm really willing to bet that it exists 2 or 3 times. Plus, it exists in your lecture. I'm willing to bet. Okay, look. This is what you're going to do. Okay. The first reaction is not reversible reaction, so you cannot jump immediately to concentration. The second one is very conducive for concentration. That's why you're trying to do this. This is second reaction. The first reaction is not like that. The first reaction doesn't deal with concentration. It usually deals with mole. Correct or not? Because it's just a one-way reaction. Of course, that's where the NOH, so you still have to deal with that, right? So it's not very conducive to concentration. It's not.
Then
So
can
I
turn
can
the ratio of concentration ratio of mole?
I mean, you did that, right? You come from mole to concentration, right? You did that, right? And then, so the mole. Okay, so the mole of H2PO4, the H2PO4, right? H2PO4 minus H2, the 0.0213 needs to minus X, right? Needs to minus X, and then the mole of the 0.01014 needs to plus X, considering that the reaction is 1111, correct? It's balanced, right?
Yeah.
So the concentration of the H2PO4 minus here will minus X because of this guy, and this one will be plus X due to this guy. X being the mole reacted lah, the mole reacted lo, the mole reacted, which will also give you, X will then give you also equal to the mole of NaOH. Conveniently lah.
Yep.
So if you can find X, you solve all your problem.
I think I might know how.
Yeah.
So
how? So propose a way.
Number of mole ratio is still the same, right? So
You're talking about the first reaction, right? Okay, yeah.
yeah, number of mole. So wait, from the first reaction, H. Wait, what's this? So actually, let's just use molar. N of HPO4 2 minus over
The mole of the mole of that okay.
it will still remain as that was it
0.476.
yeah copy of. What? Give me a sec. I need to do this myself. 0.476.
Yeah, that's the original ratio. Yeah.
So this one minus X, this one. Wait.
You're not making any sense. You're not making any sense.
This one plus X. What am I talking about?
Plus X, that one plus X. Yeah, correct. In order to get to the one that you're supposed to have, right? Yep. That's the idea from the first reaction. Your first reaction will do this, like conveniently, right? Conveniently. So can you find X? I mean, look at this equation. Mathematically, this is only one unknown equation. You certainly can do it. Certainly should be able to do it.
Yeah, so, and I have this and this already.
Right. So go ahead, do it quickly. Do it quickly. This is not a math problem. Hopefully, your chemistry problem is already done. It's not a math problem. Simple math.
X 1.55 bracket 0.0213 minus.
Right. Do all the x's, then hopefully find X.
1.585 0.5585. So 2.585x will be equals to 1.585 times 0.021 minus 0.01014. 1.0232 whatever. X will be equals to that over 2.585. 0.00913 mole.
Which is that's almost 0.001, right? But less, right?
The most like almost
Yeah,
0.01.
so it's a quite significant mole if you compare with the original mole, is what I'm trying to say. It's quite significant, right? Now you found this x, so what is this x? This x is what this guy must increase, what this guy must reduce, and also what the NaOH, same thing lah, right? So conveniently then you can find the mass load.
Answer time 23.
It's 40. 40.
40.
Correct, right? 16.1. Oh, 39. Sorry. You know, 40. Yeah, plus 40 lah. The MR of NaOH is 40. Right? 40 comma something, I don't care. Whatever.
Okay.
Quickly check the answer key. Right.
Answer key, where's answer? Where is it? There you go. Question 8. Question 8.
Aku peluk terus. Aku tegang terus sama dia. Kokonya hampir megang nyamuk. Udah dipegang. Gak bisa mau apa lagi peluk terus aja. Karena nggak bisa diam juga nih.
How is it, YanKeen? How is it?
Yeah, close enough.
Close enough. Yeah. Okay. Good. If you look at the answer key, that's exactly what they are doing.
Yeah.
See, even he say this value can be read from the graph, and now you know why they provide the graph. Right? I will argue that you're learning a lot. I will argue here you're learning a lot.
Oh man, I never do this table. This is why I always use the formula. Okay.
You nonsense lah. This table exists when you first learn the K.
Yeah.
Well, I mean when you first learn the K, but even though this is not a reversible reaction, the logic still applies, so to speak lah. Right. So I'm saying that this is probably the hardest thing they should ask you tomorrow. Just because you have to combine from a lot of things within the question. It is complicated to understand. Yes, I agree. But if you understand it, then you're in a good position for tomorrow lah. In a good position. Look at part 1. He described the reaction as the reaction you wrote lah. I suppose lah. Minus the Na lah. So I couldn't blame you lah. I cannot blame you. But I hope I impress upon you that to analyze any buffer, you need at least 2 reactions. They never write the reversible reaction. I don't think you can understand it without the second reaction, the reversible reaction. I just don't think that's a good idea. Just write it for your own sake lah, so to speak. Is what I'm right. Right? Right. Now, anything else from this question?
Not really.
Okay. Try to understand the flow of thought. Try to understand it, and hopefully you can apply it tomorrow. When they change things a bit, I feel that they won't be giving you too complicated stuff. This is already very complicated, I feel. Yeah. I feel that it's good that you understand.
All right.
One more time, they don't ask you to write the reaction. You write the reaction. Understand or not?
Yeah, definitely.
Yeah. Okay. Right. there's nothing else, then really all the best for tomorrow.
Yep.
Okay.
I know.
All right. See you.
Bye. See you.
Bye.
Bye.
Belum zamannya.